Hi, I'm Pengfei Song, and here is the course probability and stochastic process, homework 7, problem 8. Firstly, let's read the problem. Poisson process is defined by the following properties. Firstly, the number n t1, t2 of the points ti in the interval t1, t2 of length which equals to t2 minus t1 is a Poisson random variable with parameter lambda t. And secondly, if the intervals t1, t2 and t3, t4 are non-overlapping, then the random variables n t1, t2 and n t3, t4 are independent. And thirdly, at the time moment t, there is no more one Poisson point. Using the points Ti, we form the stochastic process xt equals to n0 t. And the problem A, find the means of xt, and the problem B is let's find the rt1, t2. Okay, firstly, let's solve the problem A. We know that for p x equals to k equals to e lambda to the k's and k, we have this equation. We do accumulation from k equals to 0 to infinite e to the minus lambda to the k's divided by k factorial, which equals to 1. We can get from k to infinite equals to e to the lambda, and we do a differential which equals to the lambda from k equal to 0 to infinite lambda k factorial, which equals to 8 lambda, and then which equals to from 0 to infinite k lambda k minus 1, which equals to e to the lambdas. And then we can get k equals to 0 to infinite k e to the k factorial, which equal to the lambda. So finally, we get the means of x, which equals to k equals to 0 to infinite k e which equal to lambda, and then c squared, which equal to the means of x minus eta to the square, which equals to the means of x squared minus lambda squared. And then we can get the z squared, which equals to lambda. And then for the problem B, we know firstly for T2 greater than or equal to T1, we know that xt2 xt1 equals to xt1 minus x0 and xt2 minus xt1, which are independent. So we can calculate that r t1 t2 which equals to the means of x t1 x t2 and which equals to the means of xt1 multiply xt2 minus xt1 plus xt1. And finally, it equals to lambda t1, lambda t2 minus lambda t1 plus 1 plus lambda t1, which equals to lambda t1 plus lambda t1 t2. And similarly for t1 greater or equals to t2, we can get our t1 t2 equals to lambda multiply t2 plus lambda t1 t2. So we can get that therefore we can get that the final result rt1 t2 which equals to lambda multiply the minimum t1 t2 plus lambda t1 t2. Okay, that's the solution of the problem 8. That's it. Thank you.